Hello everybody, my name is Khaled Siddiqui, and in this video I'm going to teach you how to repair the LED segment, the one that creates the digits, this guy, right there. One of the segments don't work, and how to fix that. Now this I'm doing on an HME DX100 base station. However, the procedure is the same on any item with LED segments, with only with the ones that have this kind, which is a 7 segment LED display. The 7 segment is what creates the letter, or I should say the digit 8, and out of that you can create nearly any number. Of course you can create all numbers from that, or you can also create some of the alphabetic letters with it. So here's how we do it. Now keep in mind that LEDs don't usually go bad, because LEDs are designed to last tens of thousands of hours. So when these things stop working, it means the connection or the feeding cable to that LED has gone bad. So let's get started. First thing we need to do is make sure that you don't have batteries, and we don't have any batteries because you don't want to have external power. Now I'm going to plug it in to show you what the problem is. Look right here. Let's see. There you go. You see that? See, one segment is missing? That's our problem, and that's why we need to find a solution for it. Okay, let's get started. We need to remove these 6 screws, and they are star-shaped screws. What size are they? We'll find out. The size of these screws, star-shaped screws, are T8. Okay, now I have a DeWalt powered screwdriver, but you could use a manual one. Just make sure you have the right size, which is VT8. Okay. Okay, now these screws you don't have to open. These screws are for the battery compartment. It does not need to be opened. Once you open, be careful with these screw wires. So you have to unplug the power first. Let me show you the power. This is the power. You unplug the power. This is your antenna. Now what we need to do is we need to see what is going on with the LED segment. In order to get to the LED segment, we have to go to the other side of this board, meaning we have to open 4 screws. Okay, let's unplug the cables first. We unplug all these cables. There we go. There are 6 hardwired cables and 1 plug in the center, which I will show you when we get to that. And we have to unplug the antenna. So let's do that. Now this is Phillips. We can't use this. You have to use a Phillips screwdriver. Let's see, where is our Phillips? We need to get a Phillips. This is our Phillips. Now I didn't even need to. The screws are so easily removable that I didn't even need to use. I just used this without the power tool. Okay, when you remove this, be very, very careful. When you remove this, let me go from the top. You have to remove these spacers, and these spacers have 2 washers each, so you have to be careful to make sure you don't misplace those. These spacers and washers. Put them aside. Unplug these. You simply pull them up like this and unplug these 2. Now we have 2 more screws here to open. Okay, took out those screws. Now see, I'm not gonna pull it up like that because there's a plug, a connector, so you have to do parallel lift like this, parallel lift, and there's a connector that I was talking about. This whole card is the wireless card, and the wireless card has nothing to do with the LED segments. The LED segment is on this card. This card has 4 screws. 1, 2, 3, 4. You have to unplug the battery. This is the battery. And let's get the... Let me remove this. Okay, and let's get this thing rolling. Okay, these are shorter screws. Don't mix them with these screws which you removed, which is thicker and bigger, and this is star shaped for the body. So these are 4 shorter screws. Now when you are done with this, don't pull this because there's a very delicate ribbon cable underneath. Let me show you this ribbon cable. This is a very delicate ribbon cable, so you need to pull it like that. Now let me put this back here to see which segment was bad. I made an arrow, so this is the segment that doesn't work. So I'm going to make a little mark. This way I know which one doesn't work. Now I'm going to trace the wiring to see which connection is loose, which is responsible to supply power to this. So using a magnifying glass, I did a physical inspection to check out all the connections, and I did not see any kinds of loose connection or of any sort as far as eyes could see. Like these, there are like 5 connections here, 5 soldering joints, and then 5 soldering joints on the opposite side, and all of them seem to be properly connected. So what I'm thinking is the actual LED has this segment disconnected internally, and what I'm gonna do is I'm gonna replace it. All right, how do I replace it? Where do I get these? These are cheap. You can buy these 7 segment LEDs online for a couple of dollars, maybe $5. But I happen to have another board from an older device, older intercom, HME intercom, which I'm going to use. So I'll take this out and put it there. Okay, so let's see how do we take this out, because it has 8 segments, 8 connections here and 8 connections on the other side. And if normally you use a soldering sucker, or I should say solder sucker normally, but in this case solder sucker may not be very handy, because this is a double layer, or in this case actually multiple layer, and a solder sucker, which is this device right here, by the way. This is a solder sucker. Okay, so normally you push it down and you put it on the place where you want to suck the solder, and then what you do is you release it, it sucks the solder. But that happens, that helps a lot on a single layer boards. This is a dual layer board. It has solder on both sides, so it's not gonna work. What I'm gonna do is I'm gonna group heat. I'm gonna group heat all 5 and then pull it, and then group heat all 5 from this side and pull it up. So watch how I do it. Okay, so group heating means warming up all 5 pins at once, and you have to create a long bridge between all 5 pins so you can group heat. And then you have to do that at the same time as you are applying pressure from the opposite side to pull it out. So there it is. I pulled it out. Now I'll do the same group heating on this side. I need some more solder. And voila, let's apply pressure from the back side. I'm pulling it from the back side with my other hand. And we got it out. So that's how the group heating works. You group heat. And then you have to clean up all the holes with the solder sucker to replace it with a new one. Now this is a bad board. I just used the LED from. But when I'm removing this one, I have to clear all those holes. Okay? So this is the defective unit. This is the good one. Okay? Let's remove this board. I had to put this board back in order to test it. So I need to remove this again. See that plug right there? So you have to be very careful. And pull it out like that. Okay, moment of truth. We have to remove this. We group heat it and pull it out. It helps to get a lower temperature soldering wire, because it's easier to group heat it like that. Okay, let's pull it while we heat it up. This one was much more harder, much more difficult. It doesn't want to come off easily. Okay, finally. Why is it harder? Oh, because the board is thicker and the pins are longer. It takes longer to heat it up. You can't put it upside down. See that? So you have to make sure you put it this way, and the dot goes that way. So you make a. I'm gonna make a marking. This is the side that the dot goes. Okay. Now group heat this one. Okay, we took it out. And what do we do now? We clear these holes with soldering iron. I mean soldering sucker. Or solder sucker. Okay. One hole at a time. On these you can't be doing more than one hole at a time. Okay, that's not good enough. You need the hole to be completely clear, because that's not good enough. So I'm gonna add some paste to get a better clearance. Second one was much better. Let me get a different camera angle. I have this one to remove. See that? Let's zoom in. We have 3 holes available, 2 more holes to go. That one was a good success. And this one was a good success. We have all 5 holes cleared on this side. We have this side to go now. Work on the other side. Okay. Okay. Let's see. So basically the way this works is that you push this down, right? And then you press this. This comes up and sucks the solder. So I'm going to do this now from a distance so you can see this, the whole action. That one wasn't successful. That one was not successful. Let's do this again. Okay, that one was successful. Success. Success. One last hole. Okay, so all of those were successfully removed. Let me bring this to the camera, and you can see all the holes are visible, just like it should be. And that's very good. All 10 holes, 5 on this side, 5 on that side, are visible. You can see through all of these, and there was already a dot right there telling you which direction to put the 7-digit LED segment. Identical. One had longer pins, but spacing is identical. Now what I need to do is I need to turn on the light on this thing to make sure, let's see, I could see through these holes. And I do. So if I see through these holes, that means that there is no solder blocking, so the desoldering procedure was done correctly. Now what I need to do is I need to clear the solder from the pins so it can slide in easily. Let's do that. Let's clear the solder from the pins. To clear the solder in the pin, you have to have soldering paste on the soldering iron tip. Otherwise you just simply gonna create bigger problem. There we go. Now you have to make sure they're aligned, lined up correctly and aligned. Now moment of truth to put this in. That was easily accomplished. The pins must be aligned. They can't be up and down, off alignment, because then they will not go in. You have to make sure they're all in the same line, horizontally and vertically. They're all in the same line, like lined up as a straight line. There you go. Okay, everything looks good. It's time to resolder these. So let's resolder them. You have to do resoldering, you have to do individually, and you have to make sure they don't develop solder bridge. Solder bridge means a connection between two pins with solder. That is called a solder bridge. And to prevent solder bridge, what do we need to do? We need to make sure we use soldering paste and plenty of it. Plenty of soldering paste. That's what we need to do. That seems good to me. I'm gonna use a magnifying glass to make sure I don't have any cold soldering. I don't. Now I'm gonna zoom out and plug the puppy back in and see what's happening. If we get all the segments running. Okay, so this wire first, the plug needs to go in first, then we put these wires. Okay, now I'll just plug it in temporarily to turn it on and make sure it works. And I have to plug in the power on-off switch, this temporarily. So you have to make sure it slides all the way in, and then you close the tab. It's a little tricky, but not too difficult. Okay, time to test. I plugged it in. And now I press the power. I have the same problem as I had with the other one. What does that tell us? It tells us that it is not the LED segment that's bad. It's the wire somewhere from here that's leading to this, feeding this that's bad. So let's find out. Now we are doing Diagnostic 2.0. Okay, so the million-dollar question is, how do you know which pin represents which one of these? Now, usually you have to go online and search the data sheet for this LED by looking up that port number. That's right there, the port number. I don't know if the camera can focus. I don't think it can focus. But there's a port number right there. Let me zoom. Okay, so you see that port number? You have to look it up, which is HDSP 5601-538H5 in Thailand. And then it tells you the layout and how this thing is, the diagram on which wire goes where. Okay? Now, I don't have that diagram available, so I'm going to show you the easy way how to tell which wire provides power to which one. The two center ones are common. This one, the center one, and this center one are common. So between this and this, this and that, this and this, and this and that, basically the center ones are ground. That's where you find out. So let's try. This is a battery. It's a 3-volt battery, nothing special. So if I press the center and the next is the bottom one. So what does this tell me? As you can see, this one fires up, right? Watch. See how two are firing up now? See, two are firing up like L shape. That's because this and this represents this and that. Which one represents this one? Let's find out. Okay, you have to, they're polarized. So if it doesn't work one way, you have to feed it the other way. This is ground. Okay, there you go. So what did we find out? We found out that the segment that's off, the second pin, this pin is responsible for that. So we have to trace the second pin on the board to find out why it's not working. Okay? So the second pin on the board. That means this one. Let me unplug this. So we are tracing this cable and see which resistor or which cable, this connector, or I should say conductor, and we will see which transistor or which diode is providing power to that. Okay. Now, wire tracing is a intense business. You need magnifying glasses and you need accessibility to both sides of the board. So I'm going to remove this once again. And I will be tracing this cable, this pin right there. Tracing that. Now, before I proceed, I must tell you that this is a 7-segment digital display driver. This IC chip, you can see right there, Texas Instrument. So the chip 68C 5D 5M, or you could say ULN2003, is a 7-segment driver. Now each one of these pins, like these are 220 ohm resistors. Each one of these 220 ohm resistor is leading to one of those segments. For example, you see this goes to this pin, this one goes to this pin, and then same thing with this one, goes all the way to this pin, and so on. And right here, if you notice from here, you can see that this goes right all the way to this pin, to here. So what I'm going to do is we're going to solder, refresh the soldering on all of these, which should take care of all the segments. Now this is the board from which I took the LED out, but the same exact chip is on the other board, which is still inside the unit. Okay, so you see the second pin from here, and all 7 segments, 1, 2, 3, 4, 5, 6, 7, all of these are linked to these cables, these 7. And then they're going to these. See, for example, it's written very clearly. This one says clear registration, this one says registration, this one says reset, this one says 7 segment up, 7 segment down. So this is the upper section and down section of the 7 segment. These cables are supposed to provide power to that. So what we are going to do is we're going to diagnose it by using a multimeter or continuity meter to check every segment here, this TP13, TP12, TP11, all of these, TP5, this and that, all of them, with the LED, with this. So let's find out which one is which, okay? This is in the continuity. When that's set to the continuity, what we are doing, we want to see which one we're troubleshooting. We're troubleshooting this one. So that's the second pin right here. Let's make sure this second pin gets power. Okay. So the second pin goes to here, right here. So I'm going to put an arrow. That's where the second pin goes to. Use a different. Right there. Okay. It goes right there. This goes to the second cable, the brown cable. This, the brown one. Now we will see where the brown one goes, right? Okay, so I traced the wire and I found a cold soldering which I fixed, and now let's test it. Moment of truth, we power it up and voila. We have all 8 digits all 7 segments turning on, all seven little lines, which is the 8, the digit 8. So this thing is fixed and I'm going to put it back together. To put it back together, it's reversal of what we did when we took it apart. So what do? The first thing we need to do is we need to make sure these are all in, and we make sure this one is correctly inserted. You can't insert it the other way. So on this, pay attention. One side is black, one side is clear plastic. The black side comes up like this. It comes up. Make sure it's all the way in. Only then you insert the tabs. You pull these tabs in once this is all the way in. Okay. Now we put this like that. And what do? We put the 4 screws, which was the smaller ones. found it. We have all 4 screws. These are Phillips. Remember, you need a Phillips screwdriver. Okay, all 4 screws are in. Now these require different screws. This is the battery plug, which goes here. That's where the battery plug goes in. The smaller screws, say we have 4 screws like this, thick screws. These 4 thick screws, the smaller ones go by the connector, longer ones go by the antenna. Because the screw is a non-magnetic screw, and they use non-magnetic screws for good reasons. Sometimes magnets will create radio interference. So these are the spacers. The spacers, normally they put, let me show you something. Normally they put these washers for the spacers, but I don't like it. Why I don't like it? Because I want more pressure on this. I'm okay if this curves a little bit. If this curves a little bit and more pressure is on these so they don't pop open. So let me see how much wiggle room I have, and then I will decide if I want to put those. Let's zoom out. Okay, I'm going to close the screws, tighten the screws. Okay, as long as my cables are secure and they're not coming out, I'm okay. These cables are secure and they're not moving anywhere. So these 2 screws are good. I'm fine with it. Now, what do I need? I need to plug in the DC plug, which is this guy. Battery plug, DC plug, registration, clear registration, reset, and 7 segment LCD or LED, 7 segment LED, and everything seems to be fine. Now, what do we need now? We need 6 screws, and those screws are these guys. These. I need 6 of those. Now notice, let me show you something. Notice one of them have like a ring and the others don't. Only one has a ring. That's because that's a rubber washer that sometimes when you take out the screw, the rubber washer attaches itself to the screw. Sometimes it remains there. So what you need to do is you need to make sure, there's another rubber washer. You need to make sure the ones that don't have rubber washer gets the one with the rubber washer. This doesn't. So this one, it does. Now this one rubber washer got damaged, so that's no use. That's off, no use. Voila. Let's plug it in. It's the moment of the truth. Turn it on. We have all the segments. Let me look from show you from the top. Turn it off. Turn it back on. All the segments. The letter 8 is complete. I mean number 8. When you press registration, you should get a circle. And you do, which is good. This puppy is good. We remove this. One segment doesn't work. Sign. And we also clean that little marker thingy. This is good to go. All right. So let me tell you what we found out. First, we replaced the LED, and the replacement LED was good. And it had the same problem, meaning that this LED which we took out is still good. Was that the wisest thing to do? No, it wasn't. I should have tested the LED before desoldering it. Why did I desolder? Because I wanted you guys to see how you desolder these. And this way, if you, in your case, this actual 7-segment display panel is defective, you know how to desolder it and replace it with a good one, how to know the polarity, and to realize that the center 2 pins right in the middle, the center, these are the ones that are common. Basically, I should say ground, or it could be positive depending on what kind of LED it is. And all the rest, like these two are common. These two center ones are common. And then all the rest, each one represents one segment there. So one represents this, the other represents this, one this, like this, including the dot. So that's how you repair that. I hope this was educational. Please make sure to give it a thumbs up, like, and subscribe. Thank you for watching.